Good morning, truck team. Today we have trucked all the way to the First Presbyterian Church in Lockport, New York. And it is located on what else but Church Street. Before I get into our lesson, I know you're trying to figure out why in heaven's name do I have this humongous chain around my neck. I wanted to talk to you about how we are all gathering our links together. Every one of these lessons, and every lesson in school, is a link. The links are gathered together to form this heavy, heavy chain. Now, of course, if one of the links were to be loosened or not strong, the whole chain would fall apart. And that's what I want for you. I want you to have your chain to be very, very strong. And the way to have your chain very strong is if you have a question anytime about math, you need to get help, you need to understand it, so your link will be very, very strong. All right, so let's talk about why I'm here today. I'm going to show you this beautiful window behind me. This does not do it justice, but you can come and see many windows, and here's the brochure that talks about these windows. As you can see, there were people that just went by me. They're here for a tour. This is one of the wonderful, wonderful treasures in Lockport, because this beautiful church with their beautiful community also has a hidden treasure. They have Tiffany windows. Some of you may have a Tiffany lamp at home. I do, but it's definitely not made from Louis Tiffany. It was interesting because I went on the internet to find out something about this family and this man who did these gorgeous windows. And it turns out that his father was Charles Tiffany of Tiffany's, the jewelry store in New York City. I don't know if you've ever heard of it. There even was a movie, Breakfast at Tiffany's. It's a very exclusive, very expensive jewelry store. Well, Louis didn't want any part of that. He was an artiste, and he wanted to do paintings. He didn't think he was good enough at his painting, but then he caught on to this new material, glass. And what he did was amazing. He ended up making Tiffany glass and putting them into Tiffany windows, Tiffany lamps, and just becoming a wonderful, wonderful artist. They're just beautiful. Why am I here and why am I talking about Tiffany so much? Because Tiffany used repeating a lot. Not only did he repeat nature in most of his windows, he loved nature. Not only did he repeat a lot of Bible scenes, especially in these windows, a lot of portrayals of God, of Jesus, a lot of angels, but he also repeated the technique of repeated layers of glass. And that's the Tiffany technique. I'm outside. I was inside, but they were giving tours, so I decided to come outside. And if you looked at this window from the outside, make sure you do that, you do not see faces, you don't see hands at all. Go inside and you will. That proves there's layers upon layers. The man told me one of these had 7 layers. Repeat after repeat after repeat. So why does this have to do with math? Well, I started thinking about repeating decimals and terminating decimals. But before we got into that, I have to make sure your link for your chain is very strong on decimals. Did you know that decimals, excuse me while I reach for this, decimals are really fractions? Definitely. Do you know yourself? I love decimals, and you've been using them all your life, I'm sure, because money is decimals. So if I had, let me get this way for you. If I had $2.25, $2.25, notice I have 2 places in my decimal place. 2 numbers are taking the place in the decimals. And if I wanted to change this, well, wait, let's just look. What kind of a fraction is this? This is a whole number, so I'm not going to change that. That equals a big 2. But the 25, the decimal part, is part over the whole. We did that in our first video. and it's 25 cents out of 100 cents. So decimals are always out of 100. Now, I hope this is burning your eyes, because yesterday, or was it 2 days ago, we did the video about reducing fractions. And remember, we said, how would we know what would be the factor that would divide into both of these evenly? Well, one of the rules, the divisibility rules, were 0 or 5 divided by 5. So that's what I'm going to do. I'm going to divide by 5. And I would get 25 divided by 5 equals 5. And 100 divided by 5 equals 20. That is still burning my eyes. Both numbers, the numerator and the denominator, end in a 0 or 5. Remember? 0 or 5 divided by 5. So we're going to divide by 5 again. 5 into 5 goes once. 5 into 20 goes 4. And now I have my mixed fraction from my decimal. 2 and 1/4. A whole number 2 and 1/4 is your fraction. So let's talk about, if I have a fraction, how would I make a decimal from that? So let me erase this again, and let's use that 1/4. How about? So I've got 1/4. And remember when we were doing our Michael's rule, and we were saying that use Michael's rule to reduce improper fractions? Well, guess what? You can use Michael's rule to make a decimal, but you just have to add a decimal. So I'm going to drop down, just drop that 1 down, and add a decimal. And then, you know, this is a division problem, and when I divide decimals, I just plop that right up there. So 4 goes into 10. How many times does 4 go into 10? Twice. 2 times 4 is 8. I'm going to subtract, and I end up getting 2, a remainder of 2. I'm going to keep going. So I'm going to bring down another 0. 4 goes into 20 5 times. 5 times 4 is 20. My remainder is 0. This is called a terminating fraction. I'm sorry, terminating decimal. Notice it ended. It didn't have anything left over. It just had 0 left over, so it ended. It's terminating. So we would call that a terminating decimal. It ends. It terminates. Terminating decimal. How is this different from a repeating decimal? And that's why we were here. Remember, we talked about the way Louis Tiffany repeated layers and layers of glass to get that light. If you go inside, it looks like a light is behind all of these. Well, let's start with this fraction, 1/3. If I had 1/3 and I wanted to change it into a decimal, need a decimal, you're going to just add 1, use Michael's rule again. So here I go. I'm going to drop down Michael's rule, add a decimal, and now divide. 3 goes into 10 3 times. Whoops, don't forget to pop that up there. 3 times 3 is 9. When I subtract, I have 1 left over. So I'm going to bring down the 0 again. 3 goes into 10 3 times. 3 times 3 is 9. Oh my goodness, look what's happening. It just keeps repeating, doesn't it? It goes on and on and on and on. It doesn't stop. It is called a repeating decimal. Repeating. And what we do with repeating decimals, we don't want to just keep doing 3s, we'll be here all day, is we use a repeating bar. So wherever it started repeating, right there in the very beginning, I'm going to say this equals really 0.3 or 3/10 with a bar over it. That tells me that it just keeps on going. It's repeating. It's a repeating decimal. So this is how you would take a fraction and make it into a decimal. What if we had a decimal and we wanted to make it into a fraction? We kind of did that right in the beginning, if you recall, with the 25 cents. and we put that over 100 because it had 2 places. What if it had 3 places? What if I was looking at 125 tenths, hundredths, thousandths, 125 thousandths? This time, instead of putting it over 100, it has 3 decimal places. So I'm going to say, let's put that over 1,000. Depends on how many places, how many zeros. It's burning my eyes. Have to reduce. See an even number? Divide by 2. That's not even. But I see 0 or 5. 0 or 5, divide by 5. I can divide by 5. But you know, I love money, and I'm thinking about quarters, and so I know that there's probably 4 quarters in a dollar, so this is going to end up being 5 if I divide by 25. And this is going to be 25 into 100 goes 4, so I've got 40. But I still have a 0 and a 5, so I have to go one more time, and I turn it into 1/8. And that is how you would change a decimal to a fraction. It probably is a great idea for you to copy some of the most common decimals to fractions. And I have them right here. I know we've done this in class too, but I wanted you to have it here. It's also on my blog. Which way do I have to go? This way. Okay, notice you have 1/2 equals 0.5. Then we go into the 4s. 1/4, 0.25. Isn't a quarter 25 cents? That's what they're saying. What about 3/4? What about 3/4? That would be 75 cents. Now we go into the 5s. 1/5. 1/5 of a dollar, in other words, is 20 cents. 0.2. I didn't put that 0 there, did I? 3/5, 0.6. 4/5, 0.8 or 8/10. Let's go up to the 8s here. 1/8. We already did that. 0.125. Why do you think I didn't do 2/8? Well, let's look. If I did 2 over 8, I can't do it this way. How about this way? 2 over 8. I see an even number. Divide by 2, and it would reduce to 2 into 2 once, 2 into 8, 4. It would be 1/4. And we already have our 1/4. That's why I didn't use that one. Okay, let's continue. 3/8 over on this side, 0.375. 5/8, 0.625. 7/8, 0.875. And here are our magic repeating decimals. Yep, there's more, but these are the most famous, the most common. 1/3 equals 0.3 with the line over, so if 1/3 equals 0.3, 2 of them equals 0.6. And then this very easy part on the bottom is any number over 10, you're going to put that number, put a decimal and that number. 4/10 is 0.4. Isn't that how you say it? 4/10? 7/10, 0.7. 7/10. 9/10, 0.9. That's how we say it. So I did make up a little song for you, and it's a quickie, but I think you might find it helpful. And this is the way it goes. I'd like you to copy it, please, and then I will sing it to you, and I think you'll be able to use it when you need it. It's to the tune of Michael, Row Your Boat Ashore. Use Michael's rule to reduce improper fractions. 1/10 add 1. Use Michael's rule again. I think we've done this in class. Let's try it one more time. Use Michael's rule to reduce improper fractions. 1/10 add 1. Use Michael's rule again. All right, so now you know how to take a fraction, make it into a decimal, and you know how to take a decimal and make it into a fraction. We are making our links so strong, so our chain will be strong too. So keep exploring. Come on down and see these gorgeous windows, and I'll truck with you again. Bye-bye.